Hi everyone, welcome to Chapter 18, which is all about arid landscapes. So in this portion of the course, we're going to learn about what shapes these landscapes, despite the fact that they have very little water in them. And what we are going to learn is that actually water is still the most important factor in shaping these landscapes. So arid landscapes are different in several important ways. The first is they have very little vegetation. And so when we talked about biogeography, we learned that one of the most important things contributing to biomass is water. And because there's very little water in these landscapes, they therefore have very little vegetation. Doesn't mean that they have none, but they just have a lot less than a lot of other landscapes. Um, they have lots of impermeable, non-weathered surfaces. And what this means by impermeable is that water cannot filtrate through the landscape as easily. You might think that when the earth is very, very dry, it would actually soak up water really fast, but actually the opposite is true. After a landscape has been dry for a really long time, it gets compacted and it's actually really hard for it to soak up that water. Um, and we also have a lot of loose material covering the surface. If you've ever gone out to the desert, we live very close to one. If you've ever been out to Anza Borrego, you'll notice kind of lots of gravelly, loose material covering the surface. So not much rainfall. So what happens that shapes the landscape? Still water. Water is still the most important factor. If there's one thing that I want you to remember from this chapter, it's that water is still the most important factor shaping these landscapes. They still get rain, most of them. They just don't get rain very, very often. And when it rains, it frequently pours, right? A big rain event comes in, and down it comes. You can see this picture here of this thunderstorm off in the distance. And the water doesn't percolate, right? So that water doesn't immediately seep into the ground due to those impermeable surfaces. And so that material that's sitting on top is then easily eroded away by that water because that water is not being sucked up into the ground. And here is a picture in Death Valley, and you can see very, very little vegetation. You can see lots and lots of that loose material on the ground. So you can imagine when water comes through here, it can have a really big effect. We're going to talk a little bit about flowing water in the deserts. A lot of the water that flows in the deserts can flow in a stream bed, but it's just not flowing there all the time. So again, flowing water in deserts, much, much more important than wind in most deserts. That overland flow that we talked about in the previous chapter, and ephemeral or intermittent streams. So here is an ephemeral stream bed in Bryce Canyon National Park in Utah. So when you get a rain event, doesn't necessarily have to be right there, but it could be upstream. You can get water coming down through there pretty quickly. And this will shape the landscape very, very quickly. This riverbed will change a lot after a single rain event. A lot of arid environments are also very, very old, right? So we have that differential erosion. We talked about that intrusive versus extrusive rock. So that softer rock has eroded first. You can see in the picture on the left, we have what's called an Inselberg, which I'll talk about in a second, but you can see all of that loose material that is eroded away hasn't gone very far. It's just kind of hanging out right there at the base of that landform. So Inselbergs are big, hard rocks that are left behind in otherwise flat landscapes. So Inselberg and iceberg, actually iceberg gets its name from Inselbergs. So just think about them, they're like big icebergs that are sitting there in this relatively flat landscape. We have again that mesa and scarp terrain. So we have these flat-topped landforms with horizontal layers. Oops. And you can see, actually I wanted to go here, you can see here this mesa and scarp terrain profile, and here's a picture that I took in Monument Valley at the Utah-Arizona border. And so you have the easier eroded material is gone, you have this material that's left behind. These names are basically based on the size. A plateau is much larger than a mesa, is larger than a butte, and finally what's left is a pinnacle. This will all eventually erode away. It could be later rejuvenated by tectonic uplift, but again, water is kind of flattening out that landscape. So you can see here, right here, we have the resistant, the easily eroded, the resistant, the easily eroded, and you kind of get these steps that are coming down. We also get fluvial deposition or deposition from this flowing water, right? Water flows down from the hills and it erodes as it does, and it deposits when it reaches that base. So as I showed you in that picture before, generally speaking, that material is not going to be taken away very far. It's going to be deposited right at the base. So here is a fluvial deposition called an alluvial fan. And so you can see as this hillside has been eroding, water's been flowing down, it's basically depositing this. It kind of looks like a big river delta, but it's dry, right? And you can still see a little bit of water flowing here, but as stuff is getting eroded down, it's really being deposited right at the bottom. If you drive through East San Diego County, you can actually see quite a bit of this. So an alluvial fan is a delta-like formation at the base. And areas between hills are usually very, very flat, much like a floodplain. So we're seeing a lot of the same types of landforms that we might see in more wet locations, but they're basically just dry and they're not being transported very far. And here's an example. This is Nevada's basin and range system. We talked about basin and range topography. So right now we have uplifting that's happening from tectonic forces. But if that uplifting stops, then eventually those mountains will flatten out over time. They will be eroded by water, even though there's not much water there. And again, we're talking, just to reiterate, really long time scales, right? We can see little bits of this erosion, but it will take a really, really long time for these mountains to erode. We also have deserts in endorheic basins. And remember, an endorheic basin is a place where the water that falls there is not going to reach the ocean. And so it gets very, very salty, like the Great Salt Lake. These are almost always in a rain shadow. So if you notice the case of Nevada here, where the endorheic basin is, we have mountains here. The moist air comes this way. It rains on this side of the mountains, very, very dry on that side of the mountains. You can have ephemeral lakes. You can have lakes that are just filling up briefly during rain events, usually with very, very little water, and then they'll dry up. And you can see on the right here, there's a playa where there's an ephemeral lake. There was water there sometimes. You can see that cracked landscape, very, very, very flat, but does not stay filled with water for very long. So playas are dry, flat lake beds. You can especially see these if you go out into the Mojave. And so here is Badwater Basin in Death Valley, and you can see here there's a man kayaking. This is sometimes filled with more water, can be totally dry up, but you can kayak in it because when you kayak, you actually only need a few inches of water. A very small portion of the kayak is actually sitting in the water. And so we're going to talk about wind and arid environments, which you can imagine can also be important. It is the most important factor, though, only in sandy deserts, right? Only in places where we're just having sand, we're seeing sand dunes, there's really no vegetation there. Other than that, water is the most important factor in most arid landscapes. Wind, however, is more important in deserts than other settings because you have loose material that's easily removed, and that loose material can scour rocks, especially near the ground. You can imagine if you had a bunch of sand blowing at you, how that would feel. It almost feels like sandpaper, and so it has the ability to erode away rocks. And so wind, just like water, weathers, erodes, transports, and deposits material. It does the same thing that water does, but on a much smaller scale. And again, it is only the most important factor in these very sandy deserts. And the most common feature that you see from this is sand dunes, right? Which we have sand dunes in the US. You could actually, for not that far from here, go and see them, but they're not kind of the most common of arid landscapes. And so different types of sand dunes are formed by different wind patterns. And we're going to go through the different types of sand dunes, and basically what the shape of a sand dune tells you is the direction that the wind is blowing. But first, take a picture at this wind-scoured rock in Egypt. You get this very cool mushroom formation. And what's happened here is you've had this material that has taken longer to erode away. The winds are blowing close to the ground. It's picking up that sand and it's basically sanding it down until that erodes away and that will fall over. So types of dunes, again, we want to note the wind direction. It is wind direction that is telling us, it is the shape of the sand dune that is telling us the wind direction. So the first is Barkhan. And in a Barkhan sand dune, you have wind blowing in one direction, and you kind of get these U-shaped sand dunes that are all kind of lining up together. In a transverse sand dune, you also get wind blowing in one direction, but it's much stronger wind. So you're going to get this kind of wave-like effect. When you have wind blowing from multiple directions, you're going to get a longitudinal sand dunes, which are kind of these almost like lines that form. And then when you have a lot more material and a lot more wind and it's a lot stronger, you get these star formations. And you could tell here, unlike that Barkhan and that transverse, right, these things are kind of popping up all over the place because wind is just blowing at them from all different directions. And so when we look at sand dune formation, what's happening here is the wind is blowing this way, right? So we have wind in a single direction. It's blowing some material up. It's falling down a slip face when its structural integrity can't hold it anymore, and then it's blowing it up. And if you could do some time-lapse photography, you can see that these sand dunes are actually moving like a wave, right? It just happens pretty slowly, but these things are going to generally move in this direction. So dunes caused by a unidirectional wind have a windward and a leeward side, just like mountains do, right? So the windward side is here, blowing the sand up. It can't hold on to itself anymore. It falls down that slip face, and then it's blown up onto another sand dune. So that slip face here is that steeper part of that sand dune. And you can see this dotted line here. This sand dune will eventually move over to here. This one will move over to here. So the dunes will migrate downwind over time. And that is the end of chapter 18. It's not a whole lot of material. You're going to watch a cool video about singing sand dunes and proceed on to your next exercise.